All right, what up, ladies and gents? This is the beginning unit 5.1 natural log, and everything else we've talked about integration. We talked about derivatives. We really haven't gone into logs and natural logs, things like that, and ease and stuff like that. And so we're going to do that this unit. This is called the transcendental unit. E's and pi's and all that stuff are called transcendental numbers. I'm not worried too much about the definition of those, but definition of natural logarithmic function. So the ln of x is equal to the integral from 1 to x of 1 over t dt. Let's do, oops, I forgot. There we go. Okay, so that's really what the integral is, okay? Or the ln of x, dirt. And the domain of all the natural logarithmic function is the set of just all positive real numbers, right? So all positive real numbers, because if you look at the graph, which is actually below, you can see that this is the graph of an ln function, ln of x, okay? And it doesn't exist on the other side of the y-axis. Ln of a negative value cannot exist, right? It does not exist. So we know that a couple things about properties. So the ln of 1 is equal to 0. The ln of e is equal to 1. Therefore, the limit as x approaches 0 from the positive side of the ln of x, there we go, is equal to negative infinity, right? Because the graph, if I'm going this way, the graph is going down, 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 down. So that's going to approach negative infinity. The limit of x approaching infinity of the ln of x, that's also equal to positive infinity, because this graph is going to keep on going up and up and up, and it's going to reach every single y value in the on the function, so it's going to have everything. So the ln of x we know is always increasing. That's hopefully explanatory just by looking at the graph. And the ln of x is always concave down. So it's always concave down on the whole function. Now that's the ln of x, right? So if we have ln of x minus 7 or x squared, that's going to change, right? Or that could potentially change. So this is just for ln of x. Okay. So some properties of logs, we should already know these, but if we don't, this is 0 again, right? So the ln of two numbers being multiplied together is the ln of the first number plus the ln of the second number. Okay, that's how another way I can kind of split that up. The ln of some number to a power is the power in front as the new coefficient times the ln of that number. Okay, that power comes out front. And then if I'm dividing two numbers or two expressions or whatever, I can take the ln of the top minus the ln of the bottom. So that's one way that I can split multiplication, division. I can split powers. It's just pretty easy that way, so just be aware. Okay. So the derivative of the natural log function, if we're going to let u be differentiable function of x, then the derivative of ln of x with respect to x is just 1 over x. Okay, now it's really 1 over x times the derivative of x, but this derivative is here, which is just 1, right? So it's really just times 1, which that doesn't matter, it's just 1 over x. So the ln of u is equal to 1 over u times the derivative of u. So because I'm with respect to x, it's 1 over u times the derivative, which is basically the chain rule, which is what I talked about over here. But because the derivative of x is 1, that kind of goes away. Same thing over here. Yes, it says absolute value, but because we can only have a positive value in that u piece, the ln of a positive number exists, right? Negative don't. And so that it's the same thing. So 1 over u du for the absolute value of the ln of u. All right, let's see. Find the equation of the tangent line to y equals ln of 2x. So we need to do a couple things. We need to find the derivative at 2. We need to find out what the ln of 2 times 2 is, right? So it's really the ln of 4, okay? Which I'm going to leave it as the ln of 4, right? So my ordered pair is 2 comma ln of 4. So that's that. Now I'm going to differentiate that. So if I take the derivative of the ln of 2x with respect to x, I'm going to get 1 over 2x times 2, which is equal to 1 over x. Okay, so 2's cancel, right? Now I'm going to plug in 2. So this is the derivative with 2, or at 2 there. Let me back it up there. So I'm going to say y prime of 2 is equal to 1 over 2, so that's my slope, right? And so then I'm going to get y minus the ln of 4 equals 1/2 times x minus 2. That can be your equation of the tangent line. That's fine. If you want to bring the ln over to get it in slope-intercept form, that's fine too. The derivative of the ln of 5, well, the ln of 5 is just a number, right? There's no variables there, so this is just going to be 0. Okay, it's a constant value. Find the derivative of the ln of square root of x plus 1. So the formula says I take the, so let's say f prime of x is equal to 1 over the expression times the derivative of the expression. So the derivative of this is real. I'm going to rewrite this as x plus 1 to the 1/2. So the derivative is 1/2 x plus 1 to the negative 1/2 times 1, right, chain rule. And so this is going to be, let's see, the 1/2 is going to come out front. I'm going to have another square root of x plus 1 times this square root of x plus 1. So it's times 1 over the square root of x plus 1, which is equal to 1 over 2 times x plus 1, which is equal to 1 over 2x plus 2, if you want to go and multiply that out. Okay, so that is your derivative there. Number 4, I want to find the dy dx of this ln of y equals x squared ln of x. And so how do I do this? I'm going to, this is implicit differentiation, so I'm going to find the derivative of the left side with respect to x, and then the right side with respect to x. The left side has a y in it, so when I do the derivative of here, I get 1 over y times y prime. Okay, or dy dx. I'm going to use y prime, doesn't really matter. Equals, now this is product rule, so I'm going to say x squared times the derivative of ln, which is 1 over x, plus 2x, which is the derivative of x squared, times the ln of x. And now I'm going to solve for y prime. So this is going to become, let's see, just an x plus 2x ln of x. And then this 1 over y really becomes a y over here. So I'm going to multiply this by y, and that's what I get y prime from. If you want to distribute and get xy plus 2xy ln of x, that's fine too, but I'm not going to, and that is there. Okay, let's do a couple more and we'll be done with this one. Okay, find the second derivative. So if I want to find the first derivative, we know that the y is equal to the ln of x, and y prime is equal to the outside function. This is chain rule. So the derivative of the outside function, which is 1 over x and x is ln of x, so I'm going to break that up. 1 over the ln of x times the derivative of that inside piece, which is the ln of x, which is 1 over x. So that is your answer. It's basically 1 over x ln of x. Okay, and that's your first derivative, right? So that's your y prime. The second one, I have to find the derivative of that one. I got to find a second derivative. So the double derivative, this is technically x ln of x to the negative 1. So I'm going to get negative 1 times x ln of x to the negative 2 times the derivative of the inside, which is product rule. So derivative of x is 1, so that's just ln of x, plus the derivative of ln of x is 1 over x. And let's clean that up. Negative 1 over, this is going to go to the bottom, x ln of x squared times, and this is ln of x plus 1. Okay, so now we get negative 1 times ln of x plus 1 over x ln of x squared. Hopefully that's good. Yeah, that's fine. You can leave the negative out. You can leave the negative in. That doesn't really matter, but there you go there. All right, let's get into the last one here. Now you notice this one here, I want to find the y prime, and there's just a lot of stuff here. Okay, it's going to be a crazy kind of product rule with chain rule, with quotient rule, with a whole bunch of different rules there. And so there's one way we can use logs to do this. So what I can do is I can take the log of both sides, the natural log. So let's take the natural log of both sides is equal to the natural log of all of this stuff times x squared plus 1 squared over the square root of 2x to the 3 minus 1. And because I'm doing that, I am going to then take the derivative of everything. But before I take the derivative of everything, I didn't change anything. This is not a derivative yet, right? So I'm going to keep the left side the same. So ln of y is equal to. Now what I can do is my rules over here on the right side, remember the log rules, and said if I have two things that are being multiplied, or if something's being divided, like I could split stuff up, right? So this is going to be the ln of x plus, because the multiplying things get added, plus the ln of x squared plus 1 squared, but that squared really comes out front, minus, because remember when I divide I subtract, okay, minus, and then this, the exponent on this 2x to the third minus 1 is really a half, right, because it's in your denominator, okay, times the ln of 2x to the 3 minus 1. Okay, so I took all of this long stuff here to make it now easier to find the derivatives of all of this stuff. You could, I mean, you could find the chain rule, quotient rule, product rule, and do all that stuff. It's going to be the same answer. But using logs, it might be easier. So now let's take the derivative. The derivative of ln of y is 1 over y times y prime, okay, equals what? Well, we get ln of x is 1 over x, okay. This is plus 2 times 1 over x squared plus 1 times 2x minus a half times 1 over 2x to the 3 minus 1 times 6x squared. Okay, so now let's clean this up a little bit, and we get 1 over, well actually we can get this, we can get y prime over y, okay, equals 1 over x plus, this is 4x over x squared plus 1. This is going to be minus, the 6 and 2 make a 3x squared on top, over 2x to the third minus 1. But all of this is going to be multiplied by this y down here, right? By that y. So I get y prime equals 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x to the 3 minus 1. But if I leave this y here, like that's not actually right. Well, what does y actually equal? Well, if I go back to the original equation, y is equal to that. Okay, so let's plug that in, which is x times x squared, x times x squared plus 1 squared over that square root of 2x to the 3 minus 1. And that's our answer. Now, we can clean it up if you want to go any further than that, but that's fine. Now, you could not, if you wanted to, you don't have to find the derivative using logs. You could have found the derivative, you know, using quotient rule, product rule, power rule, chain rule, all that stuff. You would have got the same answer in maybe a different format, right? They would have probably looked different, but it would have been the same kind of thing. And this way was maybe a little easier, maybe not. I don't know. That's up to you, but on to the next video. Deuces.